Hi, everyone. So today's lesson is a review, hopefully, of Pythagorean theorem, and then we're also going to learn something called the distance formula. So these notes are on Classroom if you'd like to print them and follow along. All right, let's get started. Okay, so I said hopefully a review of Pythagorean theorem because I'm pretty sure you're supposed to have already learned this in middle school. Pythagorean theorem is something that comes up throughout the year. Like 3 units from now, you may randomly have a problem where you have to do Pythagorean theorem to start off. So I'm just going to review what to do to solve using Pythagorean theorem. First of all, it's only used with right triangles. And then, as you guys probably remember, everyone always remembers this. That's the actual theorem, a squared plus b squared equals c squared. So the most important thing with Pythagorean theorem is that you're correctly identifying your a, b, and c. So the most important one is c. C is your hypotenuse, which is right here. And the hypotenuse is across from the right angle. So that's how you always know where the hypotenuse is. Then the other two sides are called legs. So this is one leg and this is another leg. The legs are your A and your B. They're interchangeable. So it doesn't matter which one you say is A or which one you say is B. So I'm going to call this one A, this one B, and your hypotenuse, the most important one, is always your C. So I always suggest for kids to first identify the hypotenuse and then figure out which one you want to call A and B. So I have two examples here, one where we're finding the hypotenuse and one where you're finding a leg. So let's take a look at number one. Again, I'm going to label my sides as A, B, and C. So this is your C because it's across from the right angle. And then we'll call this one A and this one B. So next we just plug it into a squared plus b squared equals c squared. So 4 squared plus 3 squared equals x squared. Or you could put c squared, doesn't matter. I just used x because it was in the problem. Next we square them. So remember, squaring something is multiplying it by itself, not multiplying by 2. So 4 squared is 16, not 8. 3 squared is 9, not 6. Okay, so I squared both of those. Now I'm going to add those two together. So it's going to be 25 equals x squared. Lastly, we are taking the square root of both sides to get that x all by itself. The square root of 25 is 5 because 5 times 5 is 25. If you didn't remember that, you could just use a calculator. Okay, so there's our first example. The next one, notice that the hypotenuse is here, and we're given the hypotenuse. And so we have to find one of the legs. So we're going to do the same thing, plug everything in. So it's 6.3 squared plus x squared equals 15.4 squared. Okay, and we're going to square those. 6.3 squared happens to be 39.69. And then 15.4 squared is 237.16. Okay, so now our goal is to solve for x. We're trying to get that x squared term all by itself, so we have to move the 39.69 by subtracting. So I'm going to move that over to the other side. Okay, so now we're left with x squared equals, the difference of those is 197.47. And then again, our very last step is to take the square root of both sides. This one is not a whole number, so I'm going to put the approximation symbol. It's fine if you write equals, but it's technically approximately 14.05. Okay, so there's one of each example of Pythagorean theorem. Now, Pythagorean theorem leads us to something called the distance formula. So if you were on the coordinate plane, remember like x and y axis, and you had two ordered pairs on the coordinate plane that made a segment, right? So just to show you, let me scroll down a little bit to show you this picture. Like, see this picture here? We're going to use the distance formula for this. I'm going to explain that in a second. But if I gave you this segment on the coordinate plane and I asked you to find the length of it, you could use something called the distance formula. So here's the formula right here. There's a big square root symbol, and then underneath we have x2 minus x1 squared plus y2 minus y1 squared. Now what this x2, x1, what all of that is it's just It's a label. It's a label for your ordered pairs. So see how the distance between any 2 points with coordinates x1, y1, x2, y2. You made me remember using that with like the slope formula when you have to calculate slope in algebra 1. You label them x2, y2, and x1, y1. It doesn't matter which point you say is x1, y1, and which one you say is x2, y2. They're just a label for you to know where to plug it in. That's all it is. Okay, so we're going to do a few examples of this, and then that's it. So this first one, in order to find the length of this, I need the ordered pairs of the endpoints. So x is at -2, 0, and y is at 3, -5. Okay. Next thing you want to do is label your points with x1, y1, x2, y2. Again, it doesn't matter which one you call your first point, which one you call your second point. Trying to switch to a different color here. There we go. Okay, so x, I'm going to call x my x1, y1. So that just means that it's my first x and y. My y is going to be my second ordered pair, so that's just x2, y2. It's my second x and y. Once we have that, then we plug it into the formula. So I'm going to rewrite the formula real quick, just so we have it right above where we're plugging in. So it's x2 minus x1 squared plus y2 minus y1 squared. Okay, so here we go. I'm going to plug in. First is x2, so notice 3 is my x2. So I always draw my big square root symbol. So it's going to be 3 minus, and then my x1 is -2. Now, I'm going to stop here for a sec. Notice that I already put minus because in the formula it's minus. However, my x1 that I'm plugging in is also negative. So you do have to put both of them. It's probably the most common error that kids do with distance formula. We'll deal with that double negative in a second. So now we have y2, which is -5, minus y1, which is 0. Okay, so that's what it looks like when you just plug in. Next, we're going to simplify. So right here, this is minus a -2. Remember that becomes plus. So it's really 3 plus 2, which is 5. And then -5 minus 0 is -5. Notice that I'm carefully, just like in how step 4 says, I'm carefully simplifying one step at a time. Please do not try to do it all at once. That's when mistakes happen. So now the next step is to square both of these. So 5 squared is 25. Here's another common error. -5 squared is also positive 25. A lot of times kids put -25, but it's positive. Negative times negative is positive. So then your final answer, well, in radical form, is the square root of 50. And then which is not a whole number, right? Because the square root of 49 is 7. So this is just going to be a little higher than 7. So it ends up being 7.07. Either one of these answers is fine. If you put 7.07, I'm fine with that. If you put the square root of 50, I'm also fine with that. Same thing. We'll learn later in the year to deal with radicals a little bit more. All right, so there's our first example. Oh dear. There's our first example. Okay. Here's another one. So I'm going to label my points, x1, y1, x2, y2. I'm going to rewrite my formula. x2 minus x1 squared plus y2 minus y1 squared. Okay, now we plug in. So big square root. x2 minus x1, so it's going to be -5 minus 4. y2 minus y1, 8 minus 0. So just very carefully plug everything in. Now we simplify. So -5 minus 4 is -9. And then 8 minus 0 is 8. Oops, I forgot my squared. Don't do that. Okay, so now -9 squared is positive 81. 8 squared is positive 64. So we'll add these together and we get the square root of 145, which if you put it in your calculator is around 12.04. So there's example 2. At this point, I would suggest to pause the video and try example 3. See how you do. Wait a second. Why is this saying example 4? Oh no, it is. Okay. It's example 3 of distance formula. All right. Anyway, so I would pause it, try example 5, see how you do. Okay, so the first thing that you want to do is identify the ordered pairs. So this is going to be 5, 1, and 0, negative 5. Then we're going to label. Plug in. So it's x2 minus x1, so 0 minus 5, plus y2 minus y1, negative 5 minus 1. So this is going to be negative 5 squared plus negative 6 squared. I'm going to keep going. So this is going to be the big square root symbol. The square root of, negative 5 squared is 25. Negative 6 squared is 36, both positive. So this turns into the square root of 61, which is approximately 7.81. I always round to 2 decimal places, the nearest hundredth, but if you did to the nearest tenth, that's totally fine. All right, so that's that for today. Hopefully you tried it and got it right. If not, try to find your mistake, see what you did wrong. A lot of times it has to do with negatives or plugging it in incorrectly. Okay, so that's that, and let me know if you have any questions.